Hi, in this video I'm going to be looking at the unit vector, and the unit vector is simply a vector which is 1 unit long in the direction of the vector itself. So let's work out an example. So let's say we have a vector, we'll call it A, might as well. Let's say the vector is 2, 5. The first thing we have to do is work out what the length of that vector is, and we're just going to use Pythag to work that out. So it's going to be 2 squared plus 5 squared, so that's going to be equal to square root of 29. Doesn't simplify easily. So the unit vector for A is equal to simply going to be 2 over root 29, and that's going to be 5 over root 29. So if you imagine having a vector going like that, got 1 unit long, it goes along this way in 2 over root 29, and it goes up this way 5 over root 29. Alright, so imagine squaring that using Pythagoras. You're going to get 2 squared and then over 29. So you're going to square that. 29 squared, that's going to become 4 over 29 plus 25 over 29 equals 29 over 29, which is equal to 1. So that's what the unit vector is. Okay, why do we use a unit vector? Well, here's an example. Alright, so you might say find B, which is 4 units from A in the direction of 3, 2. Alright? So that's what we've got. So if we're thinking about what we've got, and A is a vector which is, or let's say A is a point which is 3, 5. So from my x, y axes, get a picture of what this looks like. So 3, 5 is where A is. And B is a vector which is 4 units away from that in the direction of 3, 2. So B is out here somewhere. Right, so what we know is if we had this vector here, that's O, and B, isn't it? So we know that OB is equal to OA plus AB. So we know the vector. If we've got a unit vector which is 4 units long from there, then we would know what the position of B is, wouldn't we? Alright, because OB will just be the position of B. Right, so let's have a go at doing that. So the first thing I need to do is I need to find the unit vector, right, from this thing over here. Right, so if I've got the unit vector for the thing in the direction of 3, 2, right, so the unit vector B is going to be equal to, the length of that's going to be 9 plus 4, square root of 13. So the unit vector is in fact going to be 3 over 13, root 13, and 2 over root 13. That's the unit vector. So when I'm doing this addition, 0b is equal to, well, actually we'll do algebraically, 0a plus ab. Well, 0a we know is a vector which goes, and the vector from there is going to be 3, 5, isn't it? So let's just do that one then. So I should write it so you can actually read it. 3, 5, plus we've got a unit vector which is 4 units long in the direction of 3 over root 13 and 2 over root 13. So then that becomes 3, 5 plus, now we're just going to times 4 by those things, that becomes 12 on root 13, and then that's going to be 8 on root 13. So then when we're adding those two things together, we're going to get 3 plus whatever that works out to be. So it's 3 plus 12 over root 13, and that's going to be 5 plus 8 all over root 13. So that is going to be my vector OB, so therefore B is going to be a point which is 3 plus 12 over root 13 and 5 plus 8 all over root 13. Now not a very nice point because I just made that particular question up. So there's an example where we use a unit vector to find the coordinates of a point based on that information. So the unit vector is quite simple really when you think about what you've got to do with it. Anyway, have a go at some questions related to that, and I think you'll pick it up pretty quickly.